Well, friends, I have some really unfortunate news. I shared my screen this morning, but I forgot to press the record button. So now I am doing a separate Zoom video where I will talk through the notes or the homework by myself because, alas, I forgot to press record. So this might be a little bit more abbreviated than like normal because I've already gone through this once. And I know some of you guys haven't seen it, but I will, you can obviously pause the video at any time. And the great news is, as I share my screen here, I still have everything that we did this morning. I just don't have, obviously, everyone answering me as I talk through it, so I might talk through it a little bit faster. But that might actually be better for you, though, because then there's less to do. One thing I will say, if you want to know, today is the 30th, Monday the 30th. And the only thing I'm going to have you guys do today is finish this 6.4 homework. Section 6.4 is kind of big. Spent 3 days on it. Had a lot of word problems and different things. So you're just going to finish that. Tomorrow and Wednesday are going to be 6.5. So I'll post some videos tomorrow. I'll post both of them at once. I would probably watch both of them at once. If you want to split it up, watch both videos tomorrow and then do the homework on it on Wednesday. Our next Zoom video will be at 10 on Thursday. So I'm going to go ahead and share my screen now and go to what we did this morning already. Sorry that I did not record it earlier, but I'm recording it this time. So I'm heading way back to the top here. So here's the ones that we did from the 6.4 book homework. That's what we're going over right now. Whoa. What is happening? I don't actually know what's happening right now. It's super weird. Okay, so we just won't write that there. 6.4 book homework. And some of these I did, but some of these I did not go all the way through because I was like, well, since you're only half the day to finish the homework and put finishing touches on it, I was going to let some people do that. So we went over number 4, which is a colony of bacteria is grown under ideal conditions in a laboratory so that the population increases exponentially with time. At the end of 3 hours, holy smokes. So sorry, friends. At the end of 3 hours, there are 10,000 bacteria. At the end of 5 hours, there are 40,000 bacteria. How many bacteria were present initially? So there's 10,000. So this equation right here, right? This guy right here is the equation where it says 10,000 after 3 hours. And this equation right here is saying there's 40,000 after 5 hours, right? And so then what we did was we got C by itself in both of them, right? So we divided by the E to the whatever, and then set these equal to each other, right? So we set those equal to each other. And that's what we did down here. And then we were able to solve for K, right? So we moved the E to the 5K over by multiplying on both sides, divided by 10,000 on both sides. So we got 4 equals E to 2K, did ln on both sides, and then got 0.69 for K. And then we simply substituted this back into our first equation. We put 0.69 in for K, and then we solved for C, and we got C is approximately 1,260-ish. So that is number 4. Since I'm doing abbreviated things here, just feel free to let me know if there's something that you didn't understand here. Question number 5 wanted you to get to the point where you wrote an equation again, and they gave you these 2 points, 0, 2, and 2, 5. So we went ahead and plugged in 0 and 2 and saw that C was equal to 2, right? And then plug that in, and then I said, you finish on your own by finding K. That's where you just plug in 2, 5. So 5 for Y and 2 for T. Find K. One thing I will say is if they don't give you a 0 in a point, you're going to have to do some sort of substitution type thing that we did up here. But since they give you a 0, 2, we know that that 2 is the C value. So just be prepared to do some extra work when they don't give you 0. Which is kind of like what goes on in 6. 6 people ask about every year. So the top equation here is Newton's law of cooling, right? And basically this could be a really ugly problem. We did it in a little bit different of a way. The reason that it's ugly is because these two equations that I have starred in black over here are set up, right? We want the initial temperature, that's what it says. It says an aluminum beam was brought from the outside cold into a machine shop where the temperature was held at a constant 65 degrees. After 10 minutes, the beam warmed to 35 degrees Fahrenheit, and after another 10 minutes, the beam was 50 degrees Fahrenheit. Use Newton's law of cooling to find the beam's initial temperature. So, basically, the first equation is when you plug in 10 for T and 35 for the temperature that comes out, because after 10 minutes, it is that. And the second equation where you plug 20 in for T because 50 is the temperature there. And then you're looking for T0. Now we could solve that by substitution because we need K and T. And that's really gross. And that's kind of like what we did up here already, right? We solved by substitution in a way. We got both C's by themselves and set them equal to each other. Now on this problem up here, what's really interesting, I'm going to go ahead and actually erase this original guy right here because we know about him. What Jolie had done this morning was said, you know what? I'm going to say that we got 30,000 more, right? So basically at 3 hours, we had 10,000. At 5 hours, we had 40,000. But that means we have 30,000. Like if we start at 10,000, we have in 2 hours after that, we have 30,000 more. Or actually, hang on. I think this should. Hang on. Now I gotta make sure that I do my math right here. Because we're gonna have to be lning 4. Oh no, it's just saying after 2 hours go by, we would go from 10,000 to 40,000. Sorry about that. Yes. So this is actually what Jolie used to solve this one instead of doing substitution, because you divide by 10,000 and then you'd be at the exact same spot and you get the exact same K value. Now, the reason that you have to be very careful with this, although it totally works, is because this isn't actually the original, but it still gives us what K is going to happen because it's still saying that we're working with the same exponential ratios there. So that's actually how we chose to solve number 6 here. So we're looking for T0. Now 35 degrees is not the original temperature, right? You see I have that written pink over here. It is not the original, but if we use it as the starting for right now, then we can say that 10 minutes later, so this is what I have underlined in blue, we can say that 10 minutes after that, the temperature is 50 degrees. And this thing will give us our K, which is really nice. And we don't have to do substitution, although you could. So that's what we did. And you guys can look here. We just solved for K, and we got K equals 0.069. And then we go back and we use this original equation where we have to have a 20 plugged back in. Now, the reason that we have a 10 is because it's 10 minutes later and 50. But here we've got a 20 because we're saying at 50 degrees, it's 20 past the original time, right? And the original time is T naught. And then we solve for that and we get about 5 degrees. So you might want to just pause on this screen here so you can see all my work if you need to. Now, technically, we could have done substitution elimination on these first 2 equations. That would have been ugly. So that's why we did that. Now, number 7, I apologize. When you first started it, I did not have the half-life of carbon-14 is about 5,700 years. It was in the book somewhere, and I, like in an example, and I forgot to copy it down. So that's how you know how to do this one is you plug in a, if you plug in an original 1 over here and a half over here, then this is the half-life. You could use 150 if you want, but then you just solve for K and you get K equals this. But you did need to know that this was the half-life or else you're kind of in a pickle. And then I told them to finish finding T from there, right? So maybe copy that down. So I actually didn't have enough work in the actual homework on that one for you guys to finish it, so I apologize about that. Number 8 is the one that we talked about a lot. This is the one that's a little bit beyond my physics knowledge, to be honest, but it's just where my calculus knowledge is. this is the equation that they give us for the velocity, right? And the K that they give you is like what, like 59,000, something like that. And then the M is like 51 million. It's like huge. So that's kind of crazy. So if you take 59,000 divided by the 51 million, then you get this decimal number that's down here, the 0.00156. I might make that a little bit nicer. 0.001156. So then it wants to know how far it travels. So just so you know, to find out how far it travels, you have to take an integral, because the integral of velocity is position, right? And then the reason I've got pink in there right now is because we're going to plug in the 0.00 eventually. But for right now, just go, oh, we've got to go backwards from, I'll erase some things here. We've got to go backwards from this thing that I'm about to have circled right here. So how do we go backwards from that? Well, Olivia said, let's take out the 9. So it's not in there anymore. So we got a 9 in front, but then backwards from this is just itself, e to the negative 0.00156t. But then remember, with an integral, you have to attach it on the denominator, so divided by 0.001156. And so then you plug in the 0.00 to find the c. The c value ends up being how far it's gone. And so you plug in 0 for s, 0 for the t, and this whole thing goes away and becomes 1. So the e to the whole thing becomes 1. And you just take 9 divided by negative 0.001156, and you get about 7,700. Depending on where you round, you might get, I think somebody got 7,500. And then that ends up being your value there. For part B, it wants to know how long it will take for the ship's speed to drop to 1 meter per second. This is where you don't need an integral. You just plug in 1 right here, because 1 is a velocity, right? And our original thing is a velocity, right? So the other one, we had to take an integral because it wanted to know position. It wanted to know how far it traveled. Here, it wants to know velocity. So it's 1 equals 9e to that big thing, t. And then you just solve for t, and I told them to finish that on their own. Okay, and you guys can finish solving for t on your own on part B there. So for number 11, really, you could do all this work in purple here to figure out what's going on. But basically, they're just saying if it's dy dt equals negative 0.6y, this thing is the k value. So you end up right here where I am in purple. I'll go ahead and circle it in brown here. You end up right here, you know that that's the k value. And then if they tell you that there is 100 grams present at time t0, then you know that c is 100, so you end up right here. And then they just want to know how much is there after an hour, so you just plug in 1 hour and you plug it all in and you get this. So there you go. And then last but not least, number 12. Number 12, they actually wanted you to go through the steps of, like, you should know that this is your k, right? But they just wanted you to go through the integral steps, which we've already done a lot, so I probably won't explain that all in full detail, but go through the integral steps of going backwards into this equation. So this, so you guys know, this is the exact same thing as this, right? Except for negative 1/40th is plugged in for k, and you should know that from up here what they give you, right? And then the last one, they want to know, when is it 10% of its original value? That's where for part B I have over here, and you just plug in 0.1 because that's 10% of 1, and you solve for t. And I'm going to let you guys finish that on your own as well. So sorry again that, I mean, maybe you're happy that it's an abbreviated video, but that's the abbreviated homework questions because I forgot to press record earlier. So that is what I have for you. And that is what you're doing today. It's just finish solving those that we didn't finish solving all the way. If you have any other questions, just email me today. I'll be on my email, I'll check that. And then tomorrow we will do tomorrow and Wednesday we'll do 6.5, and we'll take questions on homework at 10 a.m. on Thursday is our next Zoom session. So that's what I got. And yeah, so there we go. I think for now, that's what I want to say. So I hope you guys have a great Monday, and I will talk to you later.